Okay, so everyone, can you hear me? If you could, please type one in the comment section. I'm sorry you cannot see you what they are doing. If you use WeChat, do you use WeChat?
No.
Okay, okay. I tried to broadcast on YouTube too. I just applied it, but it took
Uh-huh.
another 24 hours for it to be
Okay.
approved. So next time I will broadcast on YouTube too, simultaneously. I think they could hear me, right? Okay, the answer they could hear me very good,
Great.
and they could also see your face. So before we started, I will share a slideshow introducing
Hmm.
you, and I showed them some pictures about the conference. I kept the pictures. So let's go back to some good memory. So we will start at 9 o'clock. Now we are just chatting casually. Yeah.
That's a good part of the academic life, chatting
Yeah.
casually.
Yeah. Yeah. Sometimes by chatting casually, we got some research topic, a really good one.
Yes.
Because now I live here and I chat with myself. I also get good ideas sometimes.
Yeah.
Well, this is cool, and people are coming. Usually, at the end of a session, usually over 1,000 people will participate, but not everyone will watch, throughout.
Uh-huh.
Okay, they
Uh-huh.
come and go, they stay for several minutes, and that's normal. But
Understand.
usually, about 100 people, they will watch the
Hmm.
entire session. Yeah.
That's great.
Most of them are linguistic students in China, and some of them are
Hmm.
university teachers. Well,
Do you keep a bond with a specific university in China? They are
what do you
from
mean by a bound?
like you're more connected with people from one specific university, or it's
Uh,
really spread?
not really, because you see my ResearchGate page.
Yes.
I'm an
Yes.
independent researcher, and I call myself an academic digital nomad. I think it's a new thing. Okay,
Yes.
so
I liked it very.
after graduation, I did not go to work in a university. So I
Hmm.
chose to alternative career path. I don't know how it will unfold in the future. So
Yeah.
far, so fun. So we're going to start. Okay, it's 9 o'clock now. Let me share my screen and I
Go.
introduce you first. Just a moment. Okay. Okay. So let me check with people online. Hi everyone, I'm sharing my screen and you should be seeing some words on the screen and the face of Professor Belcavello. Do I pronounce your your family name correctly? Just correct me anytime if I.
Don't worry, it's an international name. It has Italian origins. We would say Belcavello in Italian. In Portuguese,
Belcavello.
we would say Belcavello, or
Belcavello.
less
Okay, okay. I
rounded.
prefer the
That,
correct
that's
way.
that, that's great.
Belcavello. Professor Belcavello. And if you are seeing this, the thing that I just described, please type two in the comment section. And if everything is fine, I will move on. Okay, show me a number. I have to make sure every step is correct. Good, it's so great to see Fred. Okay. Okay, good evening, everyone. Welcome to the Way of Reading session 180. It's a milestone. Tonight, we're honored to have Dr. Frederico Belcavello with us. And Professor Belcavello is a researcher at FrameNet Brazil lab. He is also a visiting researcher working with Professor Mark Turner at Case Western Reserve University. He obtained his doctoral degree from Federal University of Juiz de Fora under the supervision of Professor Tiago Torren. Professor Tiago Torren has given one guided reading session in this program before, and I believe you still remember that. So here at the last line is the ResearchGate page. You just search for the name and you could find Professor Belcavello on that page. And actually, Fred and I went back a long way. Let me show you something interesting. This is the paper he's going to guide us through this evening. But we met each other 5 years ago at a conference held at the University of Bremen. This is a picture we took at a dinner party during the conference. You see, both of us has changed a little since then. And I became bigger, fatter. I'm trying to lose some weight recently. And the dinner party was at a really good restaurant called Bremer Rathskeller. This is what the restaurant looks like inside, before we spoil the table, of course. And the one who is standing and proposing is none other than Professor John Bateman. He was the organizer of the conference. He's also I was working as a visiting student under the supervision of Professor John Bateman at that time. And the last picture, in case you are curious what I ate for that dinner, this is what I ate. I don't even know how to call it right now, but that's it. So much for the good memory. Now let's look to the future. Please join us in welcoming Professor, my friend Fred, for this guided reading session. Now, Fred, the floor is yours.
Thank you very much. Let me share my screen. You start. Okay. So very, very multimodal, this introduction with the pictures, very inspiring. And that's what I'm going to show to you today. This paper was presented last year at the EUREC conference in Torino, Italy. And it basically presents the dataset we built during my PhD time. This dataset is called Frame2, and it was named after the idea of we have this combination of the video frame with the semantic frame. That's why Frame2. And it's a FrameNet-based multimodal dataset that's going to tracking for text-image interactions in video. So I'm the first author of this paper, and the names you see there are people who actively worked at building this data set. So that was a part of us getting together, everybody who collaborated into building this data set. I'm moving from the abstract to the introduction. Here we talk about the idea of how we became to use FrameNet as a way of trying to tackle 4 images and start looking at images with the FrameNet approach, with the frame semantics approach. So since the late 90s, FrameNet has been developed as a language resource. That's the first statement. It correlates lexical units, lexical items, with background scenes, the frames. Frames include participants and props whose conceptualization is deemed necessary for assessing the meaning of lexical items. FrameNet is composed of frames and their associated roles in a network of typed frame-to-frame relations. Over the years, FrameNet was expanded to several languages other than English, and more recently, the FrameNet model has also been applied to the annotation of other communicative modes in specific images. So we started this back in we started talking about this in 2018, and we started to implement it in 2020, and then we have reported within this papers part of what we were doing back then, and now we have this dataset and some others. The main claim behind the application of the FrameNet model to other communicative modes is that, in a way equivalent to linguistic material, images and the elements in them may also evoke frames or work together with verbal text in the process of meaning making. So that's our most important claim that we did some time ago, and we are still working with it and improving this. So this data set, it works with one type of visual material. We have been working and trying to find other ways of addressing this combination of semantic frames and image in other kinds of images. So in this paper, we present the first release of the FrameSquare dataset as an expansion of FrameNet into the multimodal domain. So here we have the link for the GitHub, where you can see the dataset is available for download and for implementations, and we also have a page at Hugging Face. Both are available. The dataset is available to use. The goal is to offer a new gold standard semantic enriched fine-grained resources for multimodal NLP tasks. That's the idea behind building this dataset. So let me comment how we designed this dataset. FrameSquare is a dataset composed by multimodal objects. These objects are a result of an annotation task carried out for a specific audiovisual corpus using FrameNet categories. The annotated data accounts for both the verbal language and the video image of a Brazilian TV travel series named Pedro pelo Mundo, which means Pedro around the world. The verbal language mode is, in turn, composed of 2 types of text. One, and the most important and the most occurred, is the audio spoken during the episodes of the TV show, which was transcribed for annotation purposes. Because for FrameNet annotation, we use text, so we have to transcribe all this spoken audio. And 2, the subtitles present in those segments of the show in which the host conducts interviews in English. In general, sometimes he tries to speak other languages, but just like a bit for trying to get along with the local people. But mainly we have Portuguese and English. So this choice here was, we were thinking about cognitively the experience of the viewer. The Brazilian viewer would have an experience of the text in Portuguese. We have another work that tried to compare the original audio in English with the subtitles in Portuguese. It's a very interesting work by Myron Samagaio, another colleague from the lab. But in my case, And here we worked with all the Portuguese data. The data also includes the relations between the annotated data as mediated by the semantic structure model in the FrameNet Brazil database. That means that information about the frames, the frame elements, their relations with other frames, and relations between lexical units is included in the frame squared dataset. So we are always highlighting that FrameNet Brazil has enriched the FrameNet database with other kinds of relation, like frame to frame element relations, and also a very peculiar one that I think just FrameNet Brazil has is the qualia relations that connect lexical units and sometimes frame elements to each other. And these are a way of making the network more dense and prepared to go deeper in terms of meaning making. In as much as Frame Squared was built to serve as a gold standard dataset for multimodal NLP tasks, the notion of gold standard dataset should be regarded here with caution. The annotations in the Frame Squared dataset are meant to represent possible perspectives on the meaning construction processes, and these perspectives may be triggered by the combination of different communicative modes. Therefore, more than one set of annotations is possible, and even different annotation methodologies can be proposed to account for the multi-perspectivized nature of meaning construction. So, we have been using this corpus to different kinds of annotation. The annotation I'm presenting here is the first one we carried out. But I will detail it later, but it was mainly the idea of trying to tag visual objects on screen that are related to the verbal mode, and they're related to what is spoken in the video. We had this other task that I mentioned before, where they were analyzing the differences between the subtitles and the original audio in English, the part of the audio that was originally spoken in English. And we also have a researcher that's working on trying to get the events shown on screen independently from the text, from the spoken audio. And we also have people working on using this corpus to look for deixis and the change of deixis in some parts of it. So it's another different kind of annotation. During the process of trying to guess or understanding and defining the methodology, it was clear to us that we can approach this corpus in very different ways. We don't have one way that would be total and absolute in terms of how we should deal with this audiovisual material. So it was clear that we had to let it open to different tasks and different ways of exploring the possible relations between image and text here. So such an approach in terms of the multi-perspectivized to data annotation follows the perspectivized NLP approach as defined by the Perspective Data Manifesto and by Basili et al. So here, Valerio Basili from the University of Torino in Italy, and he's part of a group that wrote this the Perspectives Data Manifesto, as a way of trying to acknowledge the idea that when we have a data set, when we have annotations, we have perspectives, and it's very, very hard to determine that one perspective is more important or is absolute or would guide the others. So this was a way of trying to uh, get in account that people are different, and this is part of the annotation process. We don't have absolutely true in terms of annotation, and we adopted this for all the tasks we are doing in FrameNet Brazil. The idea that we don't need to care about having a lot of annotators doing the same kind of text and trying to align them and to have in agreement between annotators, because the cognitive process that we have in daily life, in real life, it's always perspectivized. So that's an important thing to note. So FrameSquare comprises data that accounts for the frame-based semantic representation of verbal language and its interaction with the frame-based interpretation of video sequences. So video sequences is the important unit here for us to understand. In specific, sequences of visual frames related with audio, especially when it contains spoken material, forming a video. We were much more interested in the sequences, and many of the sequences were like that, where we have someone talking and you're seeing some kind of image. At some points, we have just like video clips and some music and video, but the core thing of the data set is the sequences where we have someone talking. Therefore, the dataset reflects audio and video combination possibilities in terms of frames in the way they were defined by Fillmore as structured representations of interrelated concepts. So going back to the theory, to frame semantics, that's the idea. We believe that we can look for the frames in the images and match frames in the images with frames in the text, in the spoken part of the video. So the corpus to which FrameNet annotations were added comprises the 10 episodes of the first season of the Brazilian TV travel series Pedro pelo Mundo. The show premiered in 2016 on GNT, a cable channel dedicated to entertainment and lifestyle productions. 4 seasons of Pedro pelo Mundo were aired until 2019. The first season has 10 episodes of 23 minutes each. The second, third, and fourth are also composed by 10 episodes each, but these are 48 minutes long. For the purpose of this dataset, the corpus was limited to the 10 episodes for the first season, which means a total of 230 minutes of video. The plot of each episode focuses on getting in contact and exploring social, economic, and cultural aspects of a location which has experienced some kind of recent transformations. Singapore is one of the 10 episodes. Thus, what the viewer sees is Pedro Andrade, the host, trying to connect with locals instead of merely proposing a touristic view of popular places of interest. The formats of the show combine stand-ups, voiceover sequences, short interviews, and video clip sequences. It thus offers rich material as an exemplar of complex audiovisual composition for meaning making. That's why we chose it. At the time we were looking for a corpus, this one was something that we had contact in Brazil, and we believe that the way they combine image and spoken, the verbal spoken material that would be turned into text was really, really rich and interesting for us to try to understand the way we combine visual material with audio material. The 10 episodes in the first season were pre-processed for annotation following the pipeline proposed in Belcavello et al. 2022. In this methodology, 2 separate files are extracted from the videos for annotation. One, a text file containing all the time-stamped audio transcriptions and subtitles in the episode, and 2, a set of image files extracted at a 25 image frames per second rate. The resulting corpus is composed by 2,195 sentences transcribed from the 230 minutes of video. So for processing this material, the idea was having one line of text material that came from the spoken audio and the subtitles, and one line of visual material that came from the images themselves. So we now turn to the description of the annotation task carried out in the corpus. The annotation task was divided into two parts, text annotation and image annotation. So one for each line of material, one for each communicative mode. Annotation was carried out by undergraduate students trained in the task. Training strategies employed varied according to the different kinds of annotation teams. We had the permanent team and we have the temporary team assembled for the task. The permanent annotation team was composed by 12 students hired to perform several annotation tasks, including the one described here. They received monthly stipends of 700 reais for 20 hours of work. 700 reais today is something like $120. The per hour value paid to the students is circa 15% higher than the minimum wage in Brazil. Stipend values are defined by Brazilian research funding agencies. We don't have any way of making it different. We just have to follow the way the agencies determine here. So the temporary annotation teams were assembled among the students enrolled in undergraduate division hands-on annotation workshops. Each workshop is composed of 45 hours of academic work, comprising tutoring and annotation practice. 2 classes of the workshops contributed to the annotation of the dataset. A total of 32 undergraduate students were part of the temporary annotation team. The teams conducted the annotation tasks using tools specifically designed for both full text and video annotation. For the full text annotation, annotators used the same web-based annotation tool used for the global FrameNet shared annotation task. That's FrameNet Brazil web tool. For the image annotation, a semi-automatic human-in-the-loop tool for annotating static and dynamic image for semantic frames was used. It's Caron. It's described in this paper, Belcavello 2022. This tool was developed to annotate visual objects, correlate them with textual data, and label frames and frame elements evoked by them. The tool is compatible with the full text annotation tool and is composed of 2 modules. A static module for annotating picture text pairings. That's another project different from our project. And this one, that's a dynamic mode, which was the one used in the task reported on this paper for annotating images in video. So one very important thing about this, Caron was developed first as a tool for pre-processing the video and extracting images and text. And then we developed this annotation module at it. And one very important part of it was to have it compatible with the web tool we had to annotate text. Now, some months ago, these 2 tools, they were completely merged. So Caron is now part of FrameNet web tool, annotation web tool, and they work absolutely combined and integrated for any kind of task. The task followed 2 major annotation guidelines. This is very, very important. So When annotating text for audiovisual corpora, annotators should always watch the video and see the sentences in their multimodal context. The idea here was we have to make it multimodal. We cannot ignore, when we're annotating text, we cannot ignore what we see in image. When we are annotating image, we cannot ignore what we see in text that was in the audio, the original audio. So in the same way, when annotating images, annotators should always listen to the spoken audio and should also read its transcribed sentences made available in the video annotation workspace. We believe that this is the thing that made this dataset a multimodal dataset, because we look at the different communicative modes as part of that, as being part of a whole that is the audio-visual material in it, and not as different parts. So in the methodology used, there were two possibilities to carry out the full text annotation of the corpus. The first, annotators would annotate all sentences of an episode first and then start annotating images. Or two, annotators would complete the annotation of the sentences that corresponded to a sequence, then annotate image in the respective sequence and go back to the sentences of the following sequence. So in this case, both could be used. Someone could opt in to, I will annotate all the text first, and then I'm going to look at the images and try to figure out what an image is correlated with the things that are in text. Or we sometimes oriented to people to go for make a sequence in text, go back, make the correspondent sequence in video, then go back to text and go back to video. The most important thing is that you should never annotate something not considering the other communicative mode. When building the FrameSquare dataset, the annotation process started by following FrameNet's guidelines for full text annotation. Going sentence by sentence in the corpus, annotators created annotation sets for each word for which there is a lexical unit in FrameNet. For instance, a word such as the adjective creative has its meaning defined based on a scene in which a protagonist acts with a particular behavior, and this scene is the mental property frame that is shown here at figure 1. So this is the definition of the mental property frame in the FrameNet Brazil database. And what we have highlighted here are the frame elements that compound this frame. Sentence 1 in the FrameSquare dataset and shows an occurrence of the LU creative annotated for the mental property frame. The sentence is, people started being more creative again. It was originally, the sentences was annotated in Portuguese, and it came from a subtitle. So annotation plays a key role in FrameNet to the extent that it provides evidence supporting the analysis in the module. So figure 2 shows 5 annotation sets created for this sentence. Here it is. So here we have people evoking the people frame, started, evoking the process start frame, more, evoking the degree frame, creative, evoking the mental property frame, and again, evoking the event instance frame. And each of them were annotated with the frame elements for its correspondent. So let's just look here at the created the example. We have here the creativity frame element is incorporated. So here, the behavior, that's the green one, was incorporated by the lexical unit creative, and the practice is a new instantiation because the sentence doesn't specifies what is it. And the protagonists are here, the people that are annotated here. And so this note that for each of them, there are 3 layers of annotation. The frame element is the first layer here, which indicates the role other words or phrases have in relation with the target LU. For instance, people is the protagonist in the mental property frame evoked by the LU creative. The grammatical function here and the phrase type. The grammatical function is the second line and the phrase type is the third one. The new NY column, the new instantiation column, is used for indicating that core frame elements are not instantiated in the sentence, but can be inferred or that they are incorporated by the stem of the LU, which was the case that I showed here. So the video annotation, here we have a glimpse of it. Figure 3 shows the dynamic image annotation workspace. Highlighted in red is the video panel. So here we have the video panel in which annotators control video playback, draw and edit bounding boxes as these bounding boxes we have here, bounding box 63. Below it, highlighted in orange, is the annotation panel that's here, in which annotators see the indication of start and end point of the object being annotated in video. In this panel, they associate a frame with the object, select the frame element, so frame name, select the frame element, and indicate a computer vision lexical unit that would be a name for the object, and here it's graffiti, the CV name or the LU name. The CV name categorization was created for matching the object with pre-trained computer vision categories. In principle, the CV name field is to be filled in from the automatic labeling of the visual objects using classes from the Open Image Dataset v6, which were all associated to LUs evoking frames in the database. But this was not, this didn't work very well. So I can say that we probably did all the annotations manually here. But in the future, it's a possibility. Moving right, highlighted in green is the objects panel. That's here. We have a list of the video objects, which presents the list of objects created, both manually and automatically, and the metadata associated with it during annotation. In the bottom right corner, highlighted in blue, is the synthesis panel. That's here, where we can see the sentences that were previously annotated, and all the black highlighted words are the target LU that were annotated for frames. It shows a sentence annotated in the full text annotation stage, associated with its timestamps and playback controls for the video panel. Those controls allow annotators to visualize the sentences in action in the episode segment. So here, when we play this button, we can the video panel would roll the part in which the sentence is spoken. And as we are trying to match the video annotation with the text annotation, is a very important feature of this tool. And one thing I think, I'm not sure if I highlighted this very well, but one very important thing about it is the timestamps. So that's the way we can correlate image and audio precisely. And part of the study was to evaluate how much we have occurrences of frames in the same parts of video and audio? And the answer was that they are not always synchronic occurring. They are not occurring synchronically all the time. The image annotation proposed here refers to the selection of part of the screen by using a bounding box. Such a selection is understood as a correspondent visual demonstration of a frame element in a frame. In this sense, a visual object is defined as a set of bounding boxes in a time interval that is associated with the frame element. For instance, in Figure 3, looking at the video panel and at the object panel, object 63 stores the information that 1. That portion of the image refers to the behavior frame elements in the mental property frame. So this one is bounding boxes. Here we have the mental property behavior. 2. The bounding box list starts at the video frame 4770, which is also correspond to second 190.76 and ends at the video frame 4811, second 192.4. So we have this information, the start frame and the start time, the end frame and the end time here. And 3, it is also associated with the LU graffiti in the physical artworks frame for the computer vision name categorization. So here we have the CV name that's associated. So this is what compounds a visual object. And the multimodal text-oriented approach for this annotation can be explained as follows. When looking for correspondences between text and image, object 63 was annotated as the visual manifestation of the behavior in the mental property frame. On the other hand, as what is visually recognizable is a graffiti, the CV name chosen for the object was graffiti in the physical artworks frame. What is interesting here is the fact that this annotation makes it possible to associate a concrete art manifestation with the intangible idea of a mental property. And that was probably what motivated the video editor when this shot was chosen to illustrate the sentence in one. Therefore, this example shows how the frame square dataset covers the addition of meaning layers and the granularity to the FrameNet semantic representation by having annotated visual data in correspondence with textual data in a corpus. So just going back to the figure here. So people started being creative again. So criativo in Portuguese stands for creative in English. So we could make this relation. So here in the sentence, we don't have explicit way of seeing why they're saying that people are creative. And here we have an illustration for it. So the path here was to align this. We are using the same frame, the mental property frame, but here we have the frame element behavior that if we come back here, we would see it's incorporated in the sentence. So the behavior here is part of the word, but it's not tangible. And here we are making it as a representation of the behavior element. And we are also adding another frame to make the net more fine-grained and adding layers of meaning making. That's to see this as a physical artwork. So we are combining the physical artwork frame with a mental property frame, so making a blend of these frames and trying to see to model here in the data set in the way we would understand it in real life. On top of the two general annotation guidelines stated in section 2.2, the following annotation methodology guidelines were also proposed. 1. The locality of each bounding box is a shot. No bounding box should last more than one shot. If one object is present on screen throughout multiple sequential shots, one different bounding box should be drawn for each shot. It was something like the locality of annotation in FrameNet is the sentence when we are doing full text annotation. Here, our sentence would be a shot, from the beginning of a shot to the end of a shot. And 2, the beginning of a bounding box coincides with the beginning of a shot or the first appearance of the object in the shot, even if it occurs before the beginning of the sentence or the pronunciation of the target LU in the sentence. So we started annotating each visual object as soon as it appears on screen. And if we have some kind of camera movement, maybe something would appear during a shot. And if we have a still shot, probably the object would be there when we see it. One visual object can be duplicated as many times as necessary if it instantiates different frame elements, either in one same frame or in different frames. So sometimes we have one object and it correlates with a frame evoked by a noun, another frame evoked by a verb in the same sentence, and we can duplicate these bounding boxes and correlate it with these different frame elements from the sentence. The limit of asynchrony for considering a relation between a bounding box and a target LU in a sentence is the video sequence. So we are calling it a part of the video sequence. We can go back and annotate objects from seconds, sometimes some minutes before and some minutes ahead of it, or some seconds ahead of it, considering that it's part of a video sequence. If we have this chapter inside the video, we can go forward and can go back and annotate these objects. Bounding boxes can be created and annotated as referring to lexical units that are n seconds prior or ahead of the presence of the LU in the audio, if they are both located within the same video sequence and or if there is not a better connection with a closer LU. The bounding box size and position should be adjusted from frame to frame, if not automatically adjusted to match changes in object size and position. So the tool has a tracking feature that tries to when we trace a bounding box, it automatically tries to track the object, but sometimes it loses it. So it loses it. So we have to go back and adjust it so as what we have inside the bounding box is exactly what we are calling as the video object or the image information. CV names, the computer vision names, should always be chosen taking the most empirical and concrete LU possible to designate what is seen on screen. The idea of the CV named here is naming the entity that we can see on screen and trying to use this for future work where we can use computer vision to recognize these elements. And we believe that later we will be able to automatize part of it and making it work better using the model and enriching the model through the time. So the annotation outcomes. The 2,195 sentences in the corpus generated 11,796 full text annotation sets, while the images have been annotated for 6,841 visual objects. To the best of our knowledge, this is the first dataset that combines a multimodal approach and frame semantics for video annotation of visual objects. In the remainder of this section, we present the annotation outcomes in terms of the total amount of metadata associated with the corpus. We also present a qualitative analysis of the kinds of correlations made possible by the multimodal annotation method used for building frame squared. So the semantic annotation totals. The number of annotation sets, sentences, annotation sets per sentence, and video objects per episode is shown in Table 1. The numbers are very close to the ones estimated in the pilot study introducing the extension of the FrameNet model to the multimodal domain by Belcavello in 2020, with a variation of 1.7% less annotation sets and 9.75 more sentences. For the visual objects, however, the result of 6,841 visual objects represents an increase of 36.82% on the number estimated. So we have here the numbers episode by episode. It varies, but not a lot. We have something here happen in episode 2. The numbers of sentences, we see that's around 200, and so the average, it's okay. It's kind of stable. And the number of visual objects, we have one episode that has a lot, that has more, but in general, we see we are some way around 600 visual objects by episode. The average of annotations per sentence ranged from 4.34, the lowest value, to 6.53, the highest value. The corpus average of annotation sets per sentence was 5.3598. This result is below the full text annotation average of 6.1 annotations per sentence found in the FrameNet Brazil database. We can empirically associate this reduction with the perception of a great presence of short sentences in this corpus, as the corpus came from spoken audio, from people talking to each other in a very, very colloquial way. We believe that, and we could see empirically, that we have a lot of short sentences that would decrease this number. Moreover, this can be explained by the oral and very colloquial origin of the sentences in the corpus, which include a relevant number of greetings and other more pragmatic level operators that are not yet covered by FrameNet frames. We are trying to look at it and adding pragmatic frames. That's another important project that's going on. Concerning the variability of the corpus, Table 2 shows how many discrete frames and lexical units, in the case of the computer vision name, were used in each episode and in the corpus. So one line for each episode and the total in the corpus, and the rating of discrete frames, images, and for the corpus. The numbers in Table 3 show that frame variability in text annotation is much higher than in the annotation of visual objects. It is true that the number of annotation sets per episode is always higher than the number of visual objects. The ratio of video objects per annotation set is 0.57. However, the ratio of visual object discrete frame per annotation sets discrete frame is 0.64, higher than the visual objects per annotation sets value. On the other hand, the ratio of computer vision name discrete frame per annotation set discrete frame is 0.21, much lower than the visual object per annotation set value. We have empirical elements to believe that this difference may be related to the predominance of entities annotated for CV name and to the high rate of repetition of some frames during annotation, especially those evoked by many LUs such as food and beverage, for example, and also people. There was something that every time we would have a person on screen, we would annotate this, the CV name would be person. The average number of discrete lexical units used as computer vision name per episode is 71.7. The total number of 478 discrete LUs used as CV name in the corpus can be taken as the number of different categories of objects annotated as a way of comparing frame squared with other annotated other datasets. This number is considerably higher than the 80 categories of the MS COCO. It is also close to the 600 boxable classes of the Open Image Dataset V7, but with the difference that the classes in frame squared are not merely hierarchized, but organized in a more complex network of concepts that is FrameNet, using 129 different frames as presented in Table 2. So here we try to compare what we are offering in terms of categories, of visual categories, this dataset can offer. And here we use then 478 different categories for visual objects. And these categories, they are part of a network that has other relations behind them. And this was the point we were trying to compare here with this 600 boxable class for the open image dataset. Finally, Table 3 presents another aspect that supports the improved granularity for the frame square dataset. The matching ratio of only 1.6 to 1 between the frames used for the video object annotation and the ones used for the CV name. This means that 98.39% of the video objects have been associated with two different frames at the annotation level, which indicates that they are semantically enriched objects from the start, even before the establishment of other relations that form the network of frames and lexical units in FrameNet. So not only behind this categories I was showing here, we have all the frame network. We also believe that when we have an object, coming back to the list of objects, that associates mental property with physical artworks with buildings, buildings with dining, political locales with roadways, visiting with people. So this is a way of enriching this data set and make it richer in terms of what is this visual object we are seeing here. So what is going on in terms of meaning making? So we are offering objects that have this combined layers of meaning, and we believe this is much more close to the way we cognitively think when we look at an object, when we look and listen to something, and we are combining this, a lot of layers to understand what's going on. Okay, so relations in the annotated data, the example presented in section 2.2.2 demonstrated that visual elements in video shots may also evoke frames and organize their elements on the screen or work complementarily with the frame evocation patterns of the sentences narrated simultaneously to their appearance on the screen, providing different profiling and perspective options for meaning construction. In the case where the metal property and the physical artworks frames were connected, there was a blending of an entity from a visual object to instantiate a frame element in the text. So the idea of having that panel exemplifying what was the creativity. FrameNet and all its sister projects in other languages are composed of frames and their associated roles in a network of typed relations such as inheritance, perspective, and use. These are frame-to-frame relations traditionally used in most, if not every, FrameNet. FrameNet Brazil has also developed other types of relations aimed at enriching the database structure that's reported on Torrent et al., representing context in FrameNet. It's a very important paper. It's the one that Thiago presented here in a previous section. One of these relations links frame elements to the frames licensing the lexical items that typically instantiate those elements. Another relation connects core frame elements to non-core frame elements in the same frame when the latter can act as metonymic substitutes for the first, and this is reported by Gamonal 2017. An additional set of relations emerged from the indicate connections among lexical units, drawing inspiration from the concept of qualia roles established by Pustoyevsky. Derived from Pustoyevsky's four fundamental qualia categories, namely agentive, constitutive, formal, and telic, FrameNet Brazil has devised a framework of frame-mediated ternary relationships, and in this framework, a particular lexical unit is intricately associated with another lexical unit through a subcategory of quail, which is specified by a frame. In Figure 4, we show an example in which a visual object annotated for one frame instantiates another frame evoked by the LU in the text. The image specifies the text. The connection between them being made by qualia relations. The visual object annotation shown in Figure 4 comes from a fencing sequence in episode 6, Edinburgh. It shows the host exploring the Highlanders' way of fencing as a tradition kept by Scots. Pedro meets Paul MacDonald, presented as one of the great Scotland's authorities in the history of medieval battle and fencing structure. They talk about Scottish traditions, and MacDonald offers the host a practical fencing lesson. During this sequence, the subtitles in Portuguese, Sentence 2, translate the original English spoke in audio in 3. So, here the subtitle, and here's the original in English. We have always been connected to our traditions. In Sentence 2, tradições, here, that's traditions, is annotated for the custom frame. The frame element behavior is incorporated in the lexical unit, while the protagonist is annotated in the video objects 483, 484. Here we can see the protagonists are here, 483, 484, protagonists of the custom. Objects 481 and 4, oh, that's a typo here, and 482 are annotated for the frame element weapon in the weapon frame and designated as espada, that's sword, also in the weapon frame for the CV name. The arising issue would be how to represent the connection between the art of fencing, previously mentioned in 2 and triggered in the shot by the sword, combined with the custom frame evoked by tradições. The kinds of ternary qualia relations present in the FrameNet Brazil database make this combination possible. See Figure 5. So, again, what we're trying to show here is that we are connecting the swords here, trying to connect this as the representation of the tradition they are talking about. So this go back in the database here, when we have the video object 401, for example, connected with the LU sword, that's espada in Portuguese, and this LU is a frame element weapon combined that goes back to the esgrima, the fencing, and you have the word sword as a telic of the esgrima, but also the traditions. We can see the combination of the traditions LU with the esgrima, the fencing LU, as an instance of follow. So note that the existence of a ternary correlation mediated by the exemplar frame connects esgrima, fencing, to tradition, while another relation mediated by the tool purpose frame connects fencing to sword. Those two relations allow for the inference that in the multimodal setting, the behavior is that of practicing fencing. All the different interactions between visual objects and lexical units can be found in the FrameSquare data set. As I described in my PhD thesis, there are, I don't remember exactly, I believe I could account for 7 different examples. And all of them demonstrate how connecting text and image is a way of enriching a language resource with visual material. So conclusions in future work. The FrameSquare dataset exploits the complexity of an enriched FrameNet model to create meaningful connections between semiotic modes. The dataset offers the means for FrameNet to diversify its ways of representing meaning once it incorporates image as a token for establishing relations and then for meaning making. The multimodal approach to the dataset keeps the linguistic anchorage to the way the elements in it may be analyzed, explored, and used. However, the research conducted to culminate in this dataset shows that the path to approach image and meaning-making process is broad and offers other possibilities worth exploring. The next stage of the FrameSquare dataset development includes its usage to train a model for improving and start to automatically identify and tag visual objects for lexical units and frames in the computer vision name label. In parallel, we anticipate other ways of annotating other elements of visual composition. One of them is currently being designed in a pilot study, the annotation of the events perceived in image. This approach relies on the hypothesis that it is possible to identify one or more frames that account for the events shown on screen in a shot within the locality of a scene or a video sequence. And here, I acknowledge all the funding we had for doing this research, and I thank you a lot for your attention, and I'm here ready to take some comments or questions, what you need.
Oh, thank you very much. This is a fascinating work. I once listened to your presentation at a conference, the conference we talked about 5 years ago, and I see it has developed a long way from then.
Yeah.
And so audience in the video channel, if you have any question, please type in the comment section. And while you are preparing your questions, I will take the advantage of being a host to ask the first question. Well, actually I have several questions. So as you mentioned in the paper that this FrameSquare, this tool is very useful in that it connects, it covers some additional meaning construction layers. by connecting the elements in the text to the visual objects on the image.
Mm-hmm.
Well, but to me, this connection can also be retrieved by examining the co-occurrences of frames in pure texts if we have an
Yes.
extended text. So my question is, how is the connection that you find differ from the connection that could be found through co-occurrence analysis?
I believe that here we are trying to respect the idea of the locality and seeing that the synchronic occurrences would be important in terms of time, related in terms of time, in a span that's not exactly the same. Since the pilot study, we saw that we could not believe that we would hear and see something in the exact time, because this is not like a instructional video. So the genre is really important to understand. We believe that if we were going to see a recipe, put 1 cup of something, now add 1 tablespoon of something, we would see it would match a lot. But we were trying to make it flexible, and we had to establish a limit. So as in text previously in FrameNet, we would establish a limit. In the sentence, we projected this to the video sequence. So one thing is that the co-occurrence along text sometimes would only look in the level of frame and make that lexical units correlate with each other through the frame. We believe that, as my examples shown, that sometimes we can have, for example, blends when we add some layer of information. We have this second example of the qualia relation, in which we also add, so we have different things that don't seem very connected, so sword as a weapon and tradition in the custom frame, and they don't look very connected when we can establish some connection. I think this is something that's a little different in terms of approaching it. We have other things. Sometimes for many cases, we don't have a frame element instantiated in the sentence. And when we took the image, we have some object that is an instantiation of a frame element that's presented there. So we can, in this sense, complete the idea that was established from the text. But actually, I think that we doing this, it reinforced the idea that looking for long tests and looking for trying to match this kind of correlations throughout long tests and between different sentences is something that FrameNet should consider doing in next
I'm doing
steps.
now.
Yeah.
I annotated the COCA, the Corpus of Contemporary American English. I annotated the entire COCA with large language model trained on the FrameNet version 1.7. And so I have all the co-occurrence, statistics for all the frames. I list all the frames defined in the FrameNet v1.7. So regarding the example that you mentioned in the paper, the connection between the sword or fencing and the tradition, they are very likely to co-occur a lot in the text that talk about fencing as a tradition. So,
yes.
So that's why I said this kind of connection can also be retrieved by,
yes,
co-occurrence analysis. Thank you for your answer. And there's still preparing the question. If you have any question, please type in the comment section in Chinese or English. Both are okay. I'll translate into English if you type in Chinese. Maybe you find this too difficult. I've been trying all the time. In the beginning, ever since the beginning of this program, I've been trying to promote, FrameNet, and frame semantics to my colleagues in China. I'm very glad that many people have, got interested in the theory and the other practices based on the series. So I kind of contribute to the global FrameNet project in a way.
That's great.
And I have another question. In Professor Tochin's guided reading session, he mentioned it is very difficult to assign a frame to proper nouns.
Yes.
This is like a traditional problem in FrameNet. So do you think your frame squared could contribute to solve this problem in some way? I remember you mentioned that the people's name and the location of building are probably the most frequent visual object in the video. So, do you think frame squared could solve this problem in some way?
Yeah, I think that's a big problem. We had the occurrence of the people frame a lot, because every time we have a human figure in video, and it has a role, and it was tagged as a fulfilling some kind of frame element in it, we would use the CV name person for it. And the problem is that we have been talking about the bias and the issues that we have in terms of representing human figures without getting lots of the problems that we have today. For example, when you look at a person, why would you call it a man or a woman, a girl or a boy, or use all the different instantiations of people frames, or people by vocation, or people by occupation, and
By age,
this was
probably.
something. Yes, and this people by ethnicity. So we had another work with Marcelo Viridiano, who annotated images, and it was really, really interesting when they compared the situations of annotating people on images from a sentence input and without any sentence input, and how people sometimes would be biased in the way of looking at ethnicity as an important thing to highlight, and sometimes they don't, depending on having or not having a sentence guiding the comprehension. So we tried to get more neutral in terms of this, and we oriented the annotators to, when you have a person, just go for person. Don't try to label the person in the image to any of the possibilities, because we have some ethic problems with that. Okay. So in the text, sometimes they say, oh, a boy or a very young lady. Okay, that's in the text, you can use it. But for visual objects, for example, we were trying just to look for the person. So this is something that we have to think more about it, and debate about how can we infer how we are not being biased for stereotypes when you look at someone and say that this is a specific category of people. So this is something that we have to think a lot about, and I'm not sure if you have
that's
a very good
legitimate consideration. Yeah, and basically, so the video part and the textual part are annotated separately in a way. Yes. They are connected by the timestamp, of course. Yes. But you try not to influence the annotation of one by the other, even if the person is called by a boy, called by its profession, but in annotating video, you still just call it a person. It's
Yes,
to stay neutral.
for the CV name, just for the CV name.
But for the visual object name,
We would try to make what the role they are. If you have something like a boy is riding a bicycle, so riding would have
a rider.
yes, the rider, and he would be annotated as a rider, for example.
Okay.
But the CV name would be person.
I got one question from the audience, but he asked a very short question. He only asked question by 3 letters, CDA. But I get what he means.
Okay,
He probably
thank
want
you.
to ask what how to apply this data set or this tool in critical discourse analysis.
Wow.
If this is what you mean, I'm not sure.
I think that we are offering a data set that's capable, or we believe we're working to identify categories, and we can work with it to try to understand and tag and look for these categories in any kind of video. That's the goal on it. So we can use it for train a model and to look for something that the task would determine what we are looking for. And I think the task would be important in terms of organizing it. But the idea here was to build a data set that would be very rich in terms of representation of our daily life.
Thanks. Does it? Is that what you ask? I'm not sure he keeps silent now, but I still have some other questions because I'm really interested in this. What fascinated me the most is the VO and AS ratio. Well, to me, it's like the ratio reflects how much is unique to language. You cannot be seen in image or in video. Does that make sense to you?
Definitely. Since the beginning, we are trying to look at it. I think we started with the idea that although we knew that this video was very rich in terms of audiovisual composition, I believe that at sometimes in the beginning, before starting annotating, we thought that we would have more combination or repetition of what is pronounced and what we see. But then when we started working, we saw that it was not. The important thing about the CV name would look at the entities, and most of the annotation were not about entities, were about events. And having this combination of something rolled as the writer or the speaker or the cognizer, and having other CV name different that can add something for food. For that, there's one good example that's not here, but I used in other papers. That sometime Pedro is talking with a guest, and they're talking about drinking in Reykjavik, in Iceland. And they say, "Oh, so we drink. Wow, we start drinking, something like that." But we don't see the drinking itself. We see the recipient. We see the glass, and that's very interesting. The way how I show you this mug, and you see you're not seeing the drinking at all. You're seeing the recipient, but you infer that there's coffee or water or something here that I am drinking. So this is very, very interesting, the way we could making this kind of blends and making it really, really rich. I remember back then we talking about this when we are annotating a mug, for example, or a cup, and we believe in our knowledge that what we are seeing is drinking, is the drink itself, but it's never, usually it's not. We are always looking at the recipient and not the drink in itself. So we can do this because we can say, oh, I'm drinking coffee.
I know the reason
And
why, because while you are drinking, you cannot talk. So you can only do this when you say you are
yes,
drinking.
yeah. So it's very interesting. We can associate it, and we make this assumption with the recipients is associated with the food and beverage, and that is something Professor Mark Turner says there's a lot. This is looks very natural for us as in terms of human cognition, but it's really, really, really deep and complex the way we associate these kind of things.
I agree.
So we believe that we in some way we started tipping the top of the iceberg and making some more correlations to see that when we tag something in an image, this image is not exactly only the label we are getting to it. There are other things. So when we tag a sword, it's not just a weapon. What is a sword? It's a kind of weapon. Somebody uses the sword. The sword what? And the sword in the context of fencing, and fencing in the context of the Scottish culture, and so on. So this is really, really interesting, and we just think that there are a lot of things that we can and should explore. We have some people in the lab that are really, really interested in trying to consider the cinematography aspect of the video and taking into consideration the camera angles, the camera movements, and
multimodal
how do we
analysis.
Yes, how do we annotate all this? There's a lot of information. Was always not now. For now, we're just looking for the visual objects, just the objects, not this kind of information.
Well, for me, while multimodal analysis by itself is interesting, but if we combine frame analysis with multimodal analysis, I agree with you that we have to, stick to the close connection between the textual elements and the visual object. Yeah. Otherwise, it kind of violates the, the perspectival nature of meaning, stipulated in cognitive linguistics. Because language can only reflect one perspective at a time. If you analyze all the angles, all the visual information and image, then you definitely cannot correspond to a text. You need infinite text to describe one image.
Yes. Yeah. Yes.
Well, it seems that it's too technical for the audience. They do not have any question, but luckily I have more question. We are working in a similar field, and you are extending FrameNet to multimodal context. I'm trying to build a FrameNet for a genre specifically, and the academic genre, because there are FrameNet for different languages, FrameNet for different domains, like disciplinary specific FrameNet. So far, there is not a FrameNet for a genre. Well, I'm working on academic genre. I just published a paper last year, and I identified the dominant semantic frames in research articles, 84 of them, through some statistical methods. And these 84 semantic frames, I think they reflect the main interest of academia. They could be classified into three groups. One is academic communication frame, like reference to text, and the categorization. And there are also academic activity frames, like research, scrutinize, experimentation, and there are also some entity that academia may be interested in. So I call them academic interest frame. So there are 84 of them, and based on this, I hope I could build a FrameNet for this specific genre. Yeah. So, and you mentioned that you annotate the object by CV names so that you could be used, you could connect it to some computational methods to automate the process.
Yes.
And Professor Thomas Hoffman once, he also came to our program. He did a guided reading of his new book, the linguistic in the AI era, and he used large language models. So my question is, did you try automated annotation with today's multimodal AI models?
Not that we have the core computational part of the lab trying to automatize part of the annotation, while we are still refining some kind of annotation. We have been having good results using LOM for text annotation. It's been a tool that is kind of helping us in some projects. But for this data set, we haven't used anything yet. And this data set is part of a project, a bigger project, and now it's in phase of training models to, once I finished it, it's now with the core computational team to try to train and work on automatizing, but we haven't used it yet. But I believe that is something that we are going for it. We're going to some kind of pre-annotation, automatic pre-annotation, and having human in the loop, like validating the automatic annotations. I think that's how we are going to work for the next years. I'm not sure if you're starting this year or next year, but I
Is
believe
this a
that's
project in Case Reserve University?
No, my project here at Case is to enlarge the data set. We are working with journalistic videos now. So I have this from the entertainment, and now I'm working with news. And it's interesting, we just started organizing the corpus, and it's very interesting that it looks like we have more synchronicity between audio and video in news stories. And we have in this data set, for example. So the text would match more with what is shown on camera.
So that's genre difference. That's my
Yes.
interest.
Yes.
I didn't see genre interest in manifested in this way. Well, that's interesting.
Yeah.
So if you are thinking about automated annotation with multimodal AI models, I recommend you with DeepSeek. It's hot these days. DeepSeek, it's developed by a company in China. Now it's very hard on X. It's cheap and it's open source. But if you call the API, it's also cheap. It's like 1/40 of OpenAI's API. And it recognizes it's a native multimodal AI model. So it could also recognize both image and the subtitle on the screen. So I don't know how
Great.
it will be useful in your project, but I guess it would be useful.
Very interesting. Yes.
So instead of questions, I received some thanks from the audience. So many thanks
That's good.
for Professor, and many thanks for my live streams. Thank you for participating. You still have a chance to ask question if you do have any. Let me say, do I have any other questions? I write it on the page. Well, many thanks. Okay, thank you. Okay. Well, I have no more question, and if there's no more question from the audience, we will call it a day. thank you so much. Thank you so much, Fred. Thank you for joining with us. And
Thank you very much for inviting me.
I hope I could see you again in the future.
Yes.
And
Yes.
sometime next month, and Marcelo will come to this live stream sometime next month. We haven't determined on a date yet, but we will be attending if he came.
Yeah, definitely.
Okay,
Marcelo's
I hope by that time
partner here.
Yeah, I hope by that time I would have been able to broadcast through YouTube. Yeah,
his work is fascinating in matching still images.
Both of your work are fascinating.
Pictures. It's really good.
Yeah. Okay, so you're night, right? At that time, it's night at your place.
No, it's morning. It's
morning. Okay. Have a good day.
Morning, cold morning.
Okay, so you have a good day, and everybody else, good night.
Yeah, good night.
Let's see you next time. So, bye-bye.
Thank you.
Thanks.